All right, welcome everybody to this general interest webinar. It's entitled FauxConda, ways to use Conda without Conda. Just a first disclaimer, the title was just to get you here. I will actually not be using Conda unless it is in the Singularity image. Here we assume though that you already can connect to Compute Canada clusters and that you're comfortable with Python and Python environments. Like if you are not very comfortable with them, most likely you're going to be lost at some point, and you should, after this seminar, go and explore a little bit more what me and my colleague have already put down in YouTube about Python and Python environments, and read Compute Canada Python environment documentation. We also assume that you understand what is loading modules in Compute Canada systems, and if not, then again, you should go through the Compute Canada documentation. All right, so the first thing will be the question, why should you avoid Conda? Like oftentimes you hear that Conda is an environment for HPC systems. Well, actually, not necessarily. And the problem with Conda is a compatibility issue and performance issue, okay? So Conda, this is a list that we have in our documentation, but it's not comprehensive. Like the first one is that Anaconda might suboptimally install software. Since they ship binaries, then there's actually no optimization that is done for each one of the systems. They cannot know in which system is going to be used. So our software stack, we carry a fairly comprehensive software stack, is much more optimal than what Conda will ship with. Also, oftentimes can use inappropriate binaries for our architecture. So we have multiple heterogeneous architecture in our systems, and therefore the binaries might be inappropriate for what is being asked for. Especially, this is especially important. It makes actually incorrect assumptions about the location of the libraries. So oftentimes it's assuming that it's in a user local bin, for example, but our binaries are not in standard locations because we have a particular software stack. It's also enormous, and it fills your home directory oftentimes. Right? It creates a directory within your home, and and remember that your home file system is actually really, really small. So you're going to stop being able to work with in our clusters. So that's why you should not use it. Installation is a lot slower than using our Python wheels. And it also modifies your byte.c, which are going to cause conflict at some point when you're using it. Now, there are people that have used Anaconda in our systems before, and for some people didn't cause issues, for some others will cause issues. So we decided to just prevent from, ask everybody to not use Conda, so to avoid these issues. Now, all this being said, Anaconda is actually a really useful tool for especially for bioinformatics, where things are prepackaged already. But oftentimes it's mainly for your own computer, where you can add any particular configuration, and it's not going to affect anybody else. Okay, so I'm not going against Anaconda on itself, but for our clusters, we ask you to refrain from using it. Now, what options do you have? You have a particular package in Conda, and you want to use it. You want to use our clusters because you want more CPUs, more memory than what you have. So you have two options. The first one is that you're going to generate a Python environment. This Python environment, virtual environment, is not a Conda environment. Those are two different separate things. Okay? It uses similar ideas, but is not the same. And to generate this Python environment, we're going to first check for dependencies, the Python dependencies, check for program dependencies in your Conda recipe, and then load and install all the dependencies you need. Then the second option is to install the package using Conda, but not in our system, but within a Singularity image. If you haven't ever heard about Singularity Image, Singularities are containers, kind of like Docker, but we don't have Docker because Docker has a security issue. So we use Singularity. So you can extract or construct a Singularity image using Docker Hub. So if it's in Docker, you can use it with Singularity. Or you can create a bare-bone image, then install Conda and install your program within that Singularity. If you never used Singularity before, I recommend you also to go through our documentation, just docs.computecanada.ca, and search for Singularity. There is a fairly good amount of information on how to use Singularity and how to set it up. We're going to see just like a brief thing here. So Python virtual environment, what are the pros and cons of this? Like the first pro, well, or con in this case, is that it does not manage packages for you. Okay, so it's not going to, you cannot just tell, oh, install this package and that's it. No, you will have to do it by yourself. So that's a con. But it's also a pro in our systems because it allows you to actually add what we already have, right? So the Python environment actually provides you with a user writable space. And then you can install Python packages through Kit. So it's mainly geared towards Python environments, so to Python packages. But you can also install some other stuff, and we're going to see it a little bit. It will set a temporary user space when activated. So when you activate the space, the virtual environment, it's going to create and export all the paths for you. Okay, so the paths are going to be there. But the most important bit of this Python environment is that it does not clash with our systems, which Conda sometimes does, right? And the second part is it will use optimal compilation of Python programs. Now, the rest of the programs, if you compile it suboptimally, this is on you. But I'm going to show you how can you actually use our software stack within a Python environment. Okay, because one of the good things about the Python environment is that it's still aware of our system environment, and therefore you don't need to there's no clashes with the paths. Okay, so the first thing I'm going to show you. First of all, I'm going to show you first something with Annovio. So Annovio is just a package for bioinformatics processing that is set up in Conda most of the time. So I'm going to show you with this particular package what to do with to create your Python environment. So the first thing is check if you have a GitHub available, right? So in this case, Annovio has this particular Git available, so you can actually clone it. Okay, so it's very easy. You just do in our cluster, you just git clone recursive all the things in Annovio. Normally, most packages will tell you how to clone it. Sometimes you need recursive, sometimes you don't. Okay, but this is the basic command that you will follow: git clone recursive, and then the git that you want. So now we have the package there. Okay, we have the package available to us. Now we have to identify the dependencies. So how can you identify the dependencies? Normally you're going to have to go and look at the requirements file. If it's a good package, you will have a requirements file, which is normally geared towards Python packages. Okay, but also you can see that some will have the Conda recipe right there. And in the Conda recipe, you're going to have something that's called meta.jaml, which is the configuration file for Conda. So let's take a look at that file. So if we go to the Git page of Annovio, and we go to Conda recipe, we're going to check the meta.yml, and then you're going to see that Conda recipes normally have a package name, then you're going to have some build arguments, and then a requirements. The problem with Conda packages is oftentimes you don't know which one of the requirements are Python packages and which ones are binaries, right? Like the best programs actually have a complete separate thing. You have requirements.txt that is geared towards only Python, and then all the rest are set up in the requirements run. But there are some other packages that are not as clear cut. Okay, so this part is going to sound a little bit cumbersome, and for the most part it is. You're going to have to check each one of them, okay, and check if we have them in our systems. Okay, so you're going to just go module, like in this case I'm sorry, yeah, going to, so I'll have here my terminal already connected to our systems. So systems, and then you can say, like, the first one that we saw was prodigal, right? So you can do module spider prodigal. And then you're going to see that we already have prodigal and what to install, like what to load before prodigal and all that stuff. So you're going to be doing this for all the requirements that are listed here. And again, it sounds like a lot of work, but it will be worth it once you already have your environment set up. So once you already know what's going to be installed, like, or what doesn't need to be installed, but you can just load it, you can start loading it as is. So for Annovio, in this case, we're going to first create a virtual environment. Okay, and to create a virtual environment, we need to load some compiler. This is not necessary for any virtual environment, but since we're going to use some compiling in the process, I always recommend just load it, either GCC or whatever compiler you need for the software that you will need to install. That is not in our process. So in our case, we're going to load the standard environment 2020, which I always recommend you use because it's the one that is the most up to date. And then I'm going to be using Python 3.8. These are requirement is because they are, as you saw, some are requirements within Annovio. Okay. Now, virtual environment is basically just going to do virtual env download, like not download, sorry, and you give a name to the particular environment. In this case, I'm giving it to Annovio env. You can put a path, prepend a path to this, and then the environment is always going to be there. So if you set it up in Scratch, then it's only going to be good for 2 months, and then it's going to be erased. So only use it if it's transient. If you're going to use it long term, either build it on home or build it on projects. Okay? Once the environment is created, okay, you can activate it. And you activate it by sourcing a script that is in the path to the environment, bin activate. This is going to create something in here, very similar to what Conda environments have. It's going to have the name of the environment right there. And then you can start installing the requirements. So in here, we are inside of the Git that we already downloaded. And then you can just do pip install no index, and this no index is very important because this will ensure that we're going to be using our wheelhouse. Okay? If there's something that is not in our wheelhouse, you could not use no index, and then it will pull it from the internet. But we recommend against that, and instead you can send us a ticket for us to build you a wheel if it's very, very important. You can still use the internet one, but then it's not going to be optimized. That's the only downside of it. And then you do -R, and you pass the requirement txt. What? The requirement txt that is in the GitHub. Okay, so if you go in Annovio, you're going to see that the requirements txt is right here, and the requirements txt is just a list of Python packages to install. Okay, so there is all of them. Most of the, I think all of them are already in our wheelhouse. But then you might ask, well, how can I check if it's in the wheelhouse or not? Well, again, you can check in our documentation, but basically, you can ask avail will. So for example, do I have NumPy? And then avail wills is going to say, yes, I have it in these versions and for these files. Okay, this is just a refresher. You're supposed to already know this, but just to refresh it a little bit. Okay, you can search for anything. So let's say that we needed no a SciPy. I think it was also needed there, and SciPy is there. So you can actually check all the requirements to see if they are there or not, or you can just run directly the no index minus R requirements, and it's going to tell you which packages are not there, and then you can actually either install it directly from pip or ask for a request in support@computecanada.ca for the particular wheel that you want, and we can add it for you. Okay. This particular Annovio, even if you go through the documentation on how to install it, is going to tell you that NumPy and scikit-learn require some upgrading. So just after you install this, you can rerun pip install no index, and then the packages that require an update, and then you just do an dash upgrade, and then it will install in this case NumPy, scikit-learn, and pandas that are required for the Annovio environment. Now, as identifying, we already went through this. Like we can identify the modules with module spider, and it is a little bit cumbersome, but it's worth it. So you go with module spider, and you go down the list of the YAML file, okay, the meta YAML file. Now, once you have identified all the modules you want to, you would like to load them. And I would recommend you actually put all the module loads in your activate script. And this will allow you that every time that you activate your environment, all the modules that are required are going to be installed. How can you do that? You can do it basically by doing an echo or a print. That is the same. Echo is just printing something to the screen or to the standard out. And then you do module load and all the things that you need. And then you pipe it, like you redirect that, double redirect, so it's appending, not rewriting, to the virtual environment. Since you already have it activated here, you have an environmental variable called virtual env that you can use, and it's going to always point to the base of your virtual environment, right? And then being activated. What this does is going to do module load standard environment 2020 BCC 930 SciPy stack 2020B is going to be added to the activate part. This one has a breakage of line because I just kept going with all the requirements. So these are all the requirements that Annovio had. Okay, so Prodigal, MCL, Hammer, Diamond, Blast, etc., etc. Those are all the requirements that we identify in the Conda recipe. Okay, so if you go to Annovio, the Conda recipe, so we identify all this in the Conda recipe. Okay, these ones that are that prepended are, we will need to install it differently, and I'm going to show it how. Okay. Then once when you have that, like you can see that at the end of the activate script, you're going to see the module load has been already been done properly. Okay. Now, I was telling you about the missing R component. So we have not installed anything from R yet. Okay. So I will recommend that you create R library directly in the virtual environment. This will prevent from clashes with other other libraries that you've been using. Okay, so you can use just make dir in the virtual environment. You can create something called R and lib. or library. The name actually is not that important, just remember it. And then you export that libs as a virtual environment lib. So the entire path has to be exported as r_libs. That's where R is going to see where to install locally your packages. Okay. We can also, and I will recommend as well, to add this particular export in your activate environment. So every time that you activate it, you don't need to re-export anything. It's going to be right there. So what we do is we do echo export our libs virtual environment our libs into our activate script. All right. By the way, all our wheels, all our software should be loaded before you start the first activate. Okay, but afterwards it will work fine if you just add it to the activate script. Okay, now then you can use R to install the packages. So you can just do R-E and then install packages as you would do in R. But you have to pass the library as the virtual environment R-lib. Okay? And this will install the entire thing, all the packages with the dependencies. There's one dependency in the list that depends on bioconductor. We have bioconductor on it, but in this case, I installed the BioC manager in my local, so everything remains local. You can try to use the bioconductor, it's up to you. So R-E BioC manager installed, and then you can install the particular packages that you want, in this case, key value. All right, then the step 3 will be to identify which softwares are missing from your virtual environment or from our software stack. Sometimes we don't carry all the specific programs you need. And in the case that you don't want to wait for us to install software, which can take some time because our software team is extremely busy, so you can install it directly in your virtual environment. And how that will work. So in the case of Annovio, one of the missing programs is IQ3. So you can check Git or check the program that you want to install and check how to install it, right? This particular one, it's in GitHub, so you can just clone it directly. Like I'm cloning it in the base virtual environment, but you can clone it somewhere else as well. And then you go to the IQ3, and then you create a build folder in this case, and CD to that folder. Some packages require that you load a particular library. In this case, this one requires eigen. So you can load the eigen, then do the CMake. You're just following their instructions. So you just do the CMake as they ask you. But when they tell you to use a particular include directory, you will need to use our system eigen. So in this case, it's eb root eigen. And then the prefix, the install prefix, this is an important bit, is going to be the virtual environment. Okay, so if you check the virtual environment as the install prefix, all the binaries are going to be installed directly into the virtual environment. Okay, and then you just do make. This particular software, not all software have this issue, but some particular softwares do not come already executable, so you will need to change the execution times, the permissions, so IQ3 can be executed, and then you can copy it to the binary install, for example. All right? And then you can go back to the original path that you were. Now, the last step in this case of Annovio is that Annovio requires to be installed itself. So far we only install dependencies, so we can now check if the virtual environment, to install the actual pipeline. That is that. So you can go to the Annovio, wherever you downloaded the GitHub of Annovio, and then you can just do pip install dot. Okay, that's going to generate all the Python files that it requires. If it requires some compilation, it's going to do it depending on the setup.py. And that will be it for the installation in this case. Some packages do not have a setup.py, in which case you will need to do some extra steps, but we're not going to cover it in this particular webinar. Okay, and then you can test it if it works. But in this case, I would recommend to deactivate and reactivate the environment. So you deactivate, you get out of Annovio, then you source the thing back again, and then Annovio has their own test. If your particular program of interest do not have these tests, then you can just check what tests are recommended in your program, or use your own data to try to sort of test if there's any issues. Okay, so this is the first thing. Now, this is the more optimal solution. Okay, the second thing I'm going to show you is a Singularity image. The downside of a Singularity image, though, is that it might not be optimal. Okay, because again, we're going to be recreating stuff in Singularity that contains binaries that are not optimized. Like, our software team didn't spend the time they spent into installing it, therefore it's not going to be the optimal solution. But it's easy. Okay, and there are some programs that have already recipes ready for you to install. So we're going to be using Singularity, but we kind of go back and forth between Docker and Singularity. So if you are in Docker, you can search for your particular software to see if there is already a container for you. So in our case, it's going to be Annovio. And you can see that actually Annovio is there, and it says Docker pull Marin. Like, if you already read our documentation in Singularity, you don't need the Docker pull because we do not have Docker in our systems. So you just need this part, the Marin-Annovio. Okay, and once you already identify that, then you just do modulo Singularity, and then Singularity build Annovio Ceph, and then Docker dot because it's the Docker hub. / Marin / Annovio, and it's going to actually generate the image. Okay. Now, sometimes, actually quite often, packages would not ship with a container. You will hope that they will, but they don't. So we can still use a Singularity container, and it will be a little bit easier than creating the environmental variable. By using Conda, we did an environmental a Singularity container. So the first step would be to create a container. Okay, and how to create a container? It's very similar to how to build the image. The first step is just we do build, but we need a sandbox instead of an image because we're going to write stuff to it. So we need to make it a sandbox. So you generate a directory. In this case, I'm generating a CentOS. You can use any Linux-based image. CentOS is our current operating system, so you can use it directly with no problem. Right? I think that would rearrange the stuff, but okay. So it's easier to set up, but it's suboptimal, like the Singularity with Conda. Now, we already built the sandbox right here, and then we're going to use the shell option of Singularity. Shell option of Singularity, what it's going to do is it's going to run an emulator of your terminal. It's not really an emulator, but it will give you an interactive way to do stuff within the container, and that means that it will not affect the system around it. Okay, and that's why it's quite useful to have containers, and that's why it's called a container. Okay, in this case, I am mounting this user just because The bare bones CentOS do not have some of the software that like wget and Nano, so I just by mounted with -b. This W is very important because we're going to be writing to it. Okay, so we need to pass the W. The E is to clean the environment. You don't want all your variables and all your space to actually be inside of the container at this stage. Okay. Now, the first step is to install Anaconda. And to install Anaconda, the first step is to download an install script, and you just do wget, and then you go to Anaconda and check which one is the Anaconda you want. Oftentimes, these instructions are also in the particular software that you're trying to download. Okay, and then you do just bash to that particular one. I use -b here just to make it silent so it doesn't ask for everything. And then this is important, the -p and then opt-conda. This guarantees that you're going to be installing it in a particular location in the container. I use opt because it's one of those that are not mounted often, so you're not going to have clashes with it. Okay? Then you're going to activate Conda. I recommend you first create a local home. Why is this? Because oftentimes you're going to bind mount your home, or by default, home is mounted. So everything you do in home, like your basher C's changes and all that stuff, is not going to be retained the next time you come in. So the way I do it is you create a local home in the root directory of the container. Then you're going to export home into the environment. Right, there is an environment variable also in root, environment file, sorry, also in root, where you can actually export the home, local home. So every time you get into the container, the home is going to be local home instead of dash home. /home. Okay, sourcing this only does the export basically, and then I'm going to activate for the first time my Conda using the path that I assign Conda to. Okay, so is the opt Conda being activated is going to activate the base Conda right there. I need to do a Conda init, so Conda modifies my basher C, right? And as you can see, because we exported this, the basher C is actually located at localhost instead of /home. Okay. I normally source my basher C in my environment. You can skip this one, but I normally recommend just to source it just to be safe. So it's just dot, which is source for shell, is safer for shell. Localhost.basher C, and that goes also to the /environment file. Okay. Now we need to download now the recipes. Okay, and we saw that the recipes are in Conda environments. You can check also what the particular software that you're trying to install, what do they recommend and how do they recommend to install it. In Annovio, they recommend just to download Annovio environment Linux, right? And they just call the output Annovio environment 7 YAML. Okay, once you have that, you're going to create the first environment, the first Annovio environment that you get. They recommend to use the remove first, just in case you have a previous environment. Since this is a brand new container, then you don't need it. But if you have already done it, they recommend doing it. Then you're going to create the environment, and the environment is going to create by passing the YAML file that you just downloaded through the F option. Okay. Then you're going to get out of the, like, this is going to take a while, and I recommend after it finishes, just get out and get back in to check if everything has worked. Then once again back into the directory of the container, sorry. Then you would like to keep the init So all these steps are necessary because oftentimes Conda is not persistent in the container. So to make it persistent in the container, that actually as soon as you run anything in that container, you're going to be already in Annovio or in the environment that you want. So I recommend you do Conda init and put it in the environment, and then also the Conda activate Annovio 7 into the environment. Okay, then if I force that, that means that it's going to do this. You're going to be in the actual environment that you want. The next step that they do in Annovio is use conda install -1 -c by a conda hammer. This is just a particular software that it was not installed with the entire environment. Okay, so just follow the instructions of whatever is the software that you want to install. And just keep following the instructions. In the case of Annovio, you need to download the tar file and then just keep install that directly. Once you are in the activated environment, you can just do pip install Annovio-7 after you downloaded it, and that will actually create the entire, it will populate all the things that is needed for Annovio. There's one part that they say that mistune needs to be a particular version that was not in their requirements, so you need to install that part. Just keep following the instructions of any Conda installation. Okay, and then once you're already done with all this, you can get out of the image and you have options. You can run the stuff directly on the sandbox, or you can build an image of it. I recommend to give very loose permissions to this one before building it, because sometimes there are writing issues in the container. And then you just build it using Singularity build, you give a name to the image, and then the directory. The benefit of doing this is that the SIF image is much smaller than the directory. It's only one file, so it's not going to clutter your spaces, and it's easy to move from one system to another, or from one site to another, because it's a single file. Okay, so it has this thing. And then you can run Singularity as you will run it. So for example, for the test is run and the test. Okay. In this case, I have two things different here, because this test, for some reason, it tries to write in their own paths. So in the Conda paths that we already have, and this is not writable, so you will need to put it writable right here. But any other stuff, you can actually point to the writable folder, so you don't need to worry too much about it. It's just for Annovio. Now, questions and answers. Before we go to that, before I open this for everybody, help can also be reached at support@computecanada.ca or at help@trackme.ca. They both will open a ticket for you, and we will get to it. If it's about this particular webinar, please add the title of the webinar in it and say that the help is related to that. All the comments will be found. I think I have to update some of them, but will be found at staff.trackme.ca. This HLEAP, VI webinars is there. So you can also check all the commands that I just used. Same with the Singularity. This presentation is also going to be in the same folder, a PDF just in a little bit. And the recording of this presentation is going to be in our YouTube channel, so you can just do YouTube and then search for TrackNet or follow this link as you wish. So that being it, I'm happy to take any questions you have.